Hi students, today we are going to solve another problem with two inputs and one output. Earlier we have solved a problem, a simple one, then little complicated in the third video. In the first video we have seen the block diagram reduction algebra. Now we have problem number 3 where we are going to solve a problem which have two inputs, one output. Okay, I'll be drawing the problem first, then we solve step by step. So this is having two inputs. This is one input we have, which we take it as R1, and next we have in the forward path it is G1. The second summing point, you can give the numbers to the summing point if you want, plus and minus, and then we have the feedback in the given problem. This is H3 feedback because we are taking from output to input, and here we have G2, another summing point 3. Here we have negative feedback, and fourth summing point we have here. This is fourth summing point. One of the input is R2 input, plus and plus, and here we have G3, then the output C, and from the output we have the feedbacks with H2, which is connected to summing point 3, and another feedback we have with H1, which is connected to summing point 1. So this is the given problem. So first you understand the 1, 2, 3, 4 summing points we have, and coming to the feedbacks we have, this is one feedback, this second feedback, this is third feedback. So 3 feedback connections we have, output to input, and we have one input, second input, two inputs, and one output. Here we have two inputs, one output, and what they ask is individually for input R1 we get C1 output, so we get C1 by R1, that is one transfer function, and C2 by R2 we get, for R2 input we get C2 output, C2 by R2 will be another transfer function. These two we have to calculate. So two cases will be considered here in the solution. In the first case we consider R1 input is not equal to 0, and R2 input will be considered as 0. That is using like superposition theorem, at one time one input will be considered. So in case 1 R1 is not equal to 0, R2 equal to 0, that is what we consider. So when we consider R2 equal to 0, from this problem which we see, we can observe here that once the R2 is equal to 0, then though there is no meaning of the summing point 4, where we are adding this signal and this R2. If R2 is 0, summing point 4 will vanish automatically, it will not present. Okay, so summing point 4 will vanish in this, and another modification we will do here is, after summing point 4 is vanished, disappears, we shift this takeoff point here, which I am darkening with the blue color, to the output. After the summing point is vanished, we will be shifting this takeoff point beyond G3. So I'll just draw, I'm erasing this. R2 is 0. Okay, R2 is 0, and this is how we have. Now what we do is shifting this summing point beyond G3. When we shift the summing point beyond G3, as you know that we have a rule that whenever we shift the takeoff point beyond the block G3, we have to add a new block in series with H3, that is 1 by G3, right? So the step 1 will be shifting this takeoff point or branch point, it is called, beyond G3. So when we shift the branch point beyond the block G3, we have to add in series to this 1 by G3. Okay, that will be the step 1. I'll be drawing the step 1 here. where we shift the block takeoff point beyond the block. So step 1 we will take, this is a summing point. Here we have summing point 1 where we have the input R1 is there and G1 is there, summing point 2 with plus minus, then we have G2 here, then we have summing point 3, summing point 4 is vanished, summing point 3 is present. Now this is, here we have G3, and since we have shifted the takeoff point beyond G3, we have H3 here which is connected to summing point 2. We add a new block of 1 by G3 in series with H3, and this is shifted to the output C. And since we are considering only R1 input, we take it as C1 output. So this is the output, right? And now from the output we have the feedback of H2 which is connected to summing point 3. We have the feedback. Another feedback we have from the output towards the summing point 1 with the block of H1. This is also feedback, negative feedback, since here we have minus. So 1, 2, 3 summing points are left, and we have made an adjustment of adding 1 by G3 in series with H3 because we shifted this takeoff point, which I am darkening now, beyond the block G3, right? So now what we can do here is this block G3H2 we combine by using the rule 10, that is H2 is in feedback with G3, so we can write as G3 by 1 plus G3H2. Here we get plus because we have negative feedback, right? To this G3 by 1 plus G3H2, this G2 is in series, so we multiply this G3 into G2 and we combine it as a single block. So we can write it as G2 G3 by 1 plus G3H2, one block. To that complete block of G2 into G3 divided by 1 plus G3H2, this H3 into 1 by G3 is in feedback. So that we will draw now in the next step. Step 2 I will be drawing. And what we are going to do here is, in step 2, we combining G3 and H2, we get G3 by 1 plus G3H2. To that block we have G2 in series, so G2 into G3 by 1 plus G3H2 we get. That up to that block we will write here. So we have the summing point 1 with input 1 we have, and here we have the negative feedback, that is H1. We have not done any changes to this, so it will be like that only. And G1 also we have not done any changes, it will be there. R1 is the input. Here we have the summing point 2, we have not done any changes, so we get summing point 2 also with the negative feedback. And now here we had G2 that is multiplied with the block of G3 by 1 plus G3H2, so we write it as G2 into G3 divided by 1 plus G3H2. This is we get, and to this we have the output C, and this we are taking the output from the feedback, output to input. This arrow mark shows, right? Now here we have a feedback of H3 in series with 1 by G3, so we can write it as H3 by G3, and here we have feedback path from this. So to G2 G3 by 1 plus G3H2, we have a feedback of H3 by G3, that is negative feedback because here we have minus. So we will combine these two blocks into a single block, this 2 into a single block using the rule number 10. In this is G, this is our H. So what we get is G by 1 plus GH, we get G by 1 plus GH. G is G2 G3 by 1 plus G3 H2, H is H3 by G3. Will combine in the summing point 2. And I'll draw that in the next step 3. So what we will be doing is, we take as usual the summing point 1. We have not done any changes, R1, and here we have the feedback of our H1. No changes to that, we get H1 which is connected to the output, and here we have G1. Now summing point 2 will vanish and we get a big block of G by, here we have the output C. What is the big block here we get is G2 G3 by 1 plus G3 H2 divided by 1 plus, so I'll write it as G by 1 plus GH, where you know already G is G2 G3 by 1 plus G3 H2, H is H3 by G3, right? So to this G by 1 plus GH, we have G1 is in series. This G1 is in series with this block, so we can multiply G1 into G by 1 plus GH. So that will be the next step 4 we can write, and we'll substitute what is GH also here, and we have the summing point 1 as usual, no change. Here we have R1, and the feedback also we have with H1, that is also not made any changes with H1, no changes with the output. Here we have a single block is G1 G by 1 plus GH, and this output, from output we have the feedback. This is C1 because we are considering R1 input, we have this as C1 everywhere. The output is going to be C1 because input is R1. Now what we do is, finally we substitute. Now this is the feedback path of H1 we have, so to this complete block H1 is in feedback. So what we can combine using rule number 10, that is G1 G by 1 plus GH whole divided by 1 plus H1 G1 G by 1 plus GH. So that will be simplified and we get a block of, you can see here, G1 by 1 plus GH whole divided by, this is 1 plus, a little big we take, here we have C1, here we have R1 whole divided by 1 plus, again same G1 G by 1 plus GH into H1. This is the rule where we write G by 1 plus GH. Here G is our big block, this is our G, new G. G by 1 plus G into H. H here is nothing but H1. This is our new G. We have the formula G by 1 plus GH. H is our H1. So that's why we have substituted here. Now in this you can take the LCM and simplify. We can write C1 by R1 is equal to, we can write G1 by 1 plus GH whole divided by, here if you take the LCM in the denominator we get 1 plus GH plus G1 G into H1 whole divided by 1 plus GH. So this 1 plus GH here in this will get cancelled. So what we left with is G1 by 1 plus GH plus G1 G H1. Now what is G and what is H we have to substitute here. What we have taken here, H is H3 by G3 and G is G2 G3 by 1 plus G3 H2. This is G is G2 G3 by 1 plus G3 H2 and H is H3 by G3. That we have to substitute in the beginning, or here also you can substitute. So we will be substituting in place of G, G2 G3 by 1 plus G3 H2. This is in place of G into G1 is there, whole divided by 1 plus, you can take out G common, H we will be substituting is H3 by G3 plus G1. G1 as usual it is G1 only, G1 H1. Now in place of G, here also in the denominator we will be substituting G is nothing but this one, G2 G3 by 1 plus G3 H2. So that will be another step we can write. So we get G1 G2 G3 whole divided by 1 plus G3 H2 whole divided by, now in place of G we will be writing G2 G3. G2 G3 will be writing by 1 plus G3 H2. In place of G we will be writing this into H3 by G3 plus G1 H1 we can write. So now here you can take the LCM of 1 plus G3 H2, and the numerator we have this 1 plus G3, denominator of numerator, that will get cancelled. You have to finally complete this, because at the end this is a LAQ, so you have to simplify up to the end. So when we take the LCM, here we get 1 plus G3 H2 plus G2 G3, and here we have H3 by G3 plus G1 H1 whole divided by, we have 1 plus G3 H2. So this 1 plus G3 H2 and this 1 plus G3 H2 will get cancelled. The final answer we get is G1 G2 G3 whole divided by, we get 1 plus G3 H2 plus G2 G3 into H3 by G3 plus G1 H1. This is case 1 we have completed, where we calculated C1 by R1. This is case 1, we calculated C1 by R1. Case 2 we have to calculate C2 by R2. In this, where we consider R1 is equal to 0 and R2 is not equal to 0, this will be considered in case 2. And the summing point 1 will vanish, because in the summing point 1, I will going back to the problem. Summing point 1 we have given the R1. Here we are considering R1 is equal to 0, summing point 1 will vanish. And other than the summing point 1, we have to find out the simplified block diagram. So when we vanish the summing point 1, we get here it as G1. In the negative feedback here we have, so we take it as minus H1, and the summing point 2 will be present. Summing point 2 is present with the negative feedback, and here we have to this, we are taking it as H2 is the feedback path, and here we have G2 is there, and here we have the summing point 3 will be there, the summing point 3, the summing point 2, summing point 1 is vanished, and here we have plus and minus negative feedback with H2, and here we have the summing point 4, because R2 we have considered, summing point 4 will be present here, summing point 4 is there, and here we have G3, and the output we have here C2, and from the output we have this feedback of H2, and this minus H1 is also there from the output C2. Now we will be simplifying. In this we are going to next combine the blocks G1 and minus H1 which are in series. So we get minus G1 H1 block, and shifting the summing point of H2 before G2 and rearranging the branch points. So this will be the step 1. Combining the blocks in cascade. That is G1 and minus H1, and shifting the summing point of H2 before G2 and rearranging the branch points. The branch points. This is the step. So what here we are going to do is this summing point 3 will be shifted before G2. Right. Now step 2, we have interchanging the summing points. Step 2, interchanging the summing points. Interchanging the summing points and combining the blocks in cascade. And combining the blocks in cascade. Which blocks here we are going to combine is when we shift the branch point related to H2 beyond G2, we get 1 by G2 in series with H2. When we shift the summing point 3 before G2, we'll be adding a new block of 1 by G2 along with H2. So that block diagram will be drawing here. So we combined G1 minus H1. So we take it as minus G1 H1, and we have interchanging the summing points. That will be the step we'll write here, plus minus, and here we have G2, and here we have the actual input R2 which we have given, which we can take it as R also. This is a summing point. The output of this is given to G3, from where we have the output C. C2 we take. Now here, from here we have the feedback point with H2. We shifted this summing point beyond G2, so we will be adding 1 by G2 along with series. Since we shifted this summing point beyond G2, so we will be adding a block of 1 by G2. Right. So that is the modification, and here we have taken the feedback. Now we will be combining these two blocks, 1 by G2 H2 we can combine, and this H2 by G2 is become as a single block we get, and combining parallel blocks, eliminating feedback path will be doing. After interchanging, what we get is this block in step 3. Again one more block we will draw after doing the changes, plus minus, This is the summing point. Here minus plus. Here G2 we have. Here we have the H2 feedback. After interchanging the summing points, we get this as H2. And here we have the summing point for which we give the input R. R2 we can take plus and minus. And here we have G3, which is connected to the output C2. And here we have the feedback H2 by G2, which is connected to the summing point 1. Now here we have the feedback with this minus G1 H1. From the output we have the feedback. Right. Now this one we can combine H2 G2, and we can write in this place it is G2 by 1 plus G2 H2. That will be combined, and this H2 by G2 and minus G1 H1 we have, both are in forward path. Both are starting is the same input here. It is we are having from output to input, but both are having the same input. So H2 by G2 minus G1 H1 are in forward path. So we'll be adding those two, and it will be simplified further. So what we get in the next step 4, we get one block which is nothing but the feedback path of G2 by 1 plus G2 H2. Then we have the summing point for which we are giving the input R, and then here we have as usual G3 is there, and here we have the output C2, and we are taking the feedback with parallel path. We have 2 minus G1 H1 is in forward path with H2 G2, that is also minus, so H2 G2 we get here. This is in feedback, it is coming from output to input, and here we have plus, and this is plus to the summing point. So here we can combine the blocks in cascade. This is in cascade with this, both are in series. These two, this one and this one are in series, so we can cascade, blocks are combined. So it is combining the blocks in cascade, combining the blocks in cascade. So we'll write another last diagram we have here. So we can write like this: input R2 we have, just making it horizontal instead of straight. Input we have here, we have G3. After combining the parallel paths we get, this is plus plus, and here we have these two, the circle with the red color are in cascade, so we multiply those two, so we get a little big one here, and feedback with C2. So what it is we get is, when we multiply we get it as G2 G1 G2 H1 plus H2 divided by 1 plus G2 H3 into G2. This is what we get after multiplying these two blocks. Right. Now with G3, this block is in positive feedback. With G3, this block which I made with black color square is in positive feedback. So suppose if we take it as G and it is H, since it is in positive feedback, we get C2 by R2 as G by 1 minus GH. G by 1 minus GH, where our G is G3 and H is this big one, that is minus G2 into G1 G2 H1 plus H2 by 1 plus G2 H3 into G2. That one is our H. So if we substitute these values in this and do the simplification, G is nothing but G3 simple by 1 minus G3 into our H is the bigger one here, that is minus G2 G1, that will substitute here. So we get minus G2 we have into G1 G2 H1 plus H2 divided by 1 plus G2 H3 into G2. This is what we have in place of H. So if you take the LCM for the denominator, 1 plus G2 H3 will be the LCM we get. And when we simplify this, 1 plus G2 H3 will be in the denominator, and this G2 will get cancelled, this minus G2, this plus G2 will get cancelled. And if you take the LCM in the denominator, that goes into numerator, that is 1 plus G2 H3, and otherwise I'll write another step here. So we get G3 whole divided by, when we take the LCM, this 1 plus G2 H3, we get 1 plus G2 H3 minus of minus, it becomes for this, plus G3 into G1 G2 H1 plus H2 whole divided by 1 plus G2 H3. So this denominator goes into numerator and we get G3 into 1 plus G2 H3 whole divided by the denominator again, right? This goes into numerator. So finally we get G3 into 1 plus G2 H3 whole divided by 1 plus G2 H3 plus G3 into G1 G2 H1 plus H2. This will be the final answer. Thank you for watching. Please subscribe and share my video. Thank you.